Okay, so again, it shows that you're using muscles to breathe, but why do we breathe? Well, we breathe to exchange gases, right? So they were exchanging gases in a very awkward way, but that's what was happening. So what are you trying to do when you breathe? Not only bring in oxygen and put it into your bloodstream and distribute it to your tissues, but you also want to remove carbon dioxide from your tissues and get rid of it. So things that your oxygen and carbon dioxide, they're very small molecules. They leave and enter your tissues freely. And I always hear this myth, like, and I won't get political, but they say like things like this, like our masks, right? Like surgical masks. They say you're breathing your own carbon dioxide. It's like, have you looked at the size of a carbon dioxide molecule, and then also the size of that this filters? It's like putting it's like Swiss cheese compared to it's not going to trap all these carbon dioxide molecules. Now the thing is that diffusion doesn't require energy because again diffusion is a passive process. It doesn't require transporters. And the thing is that diffusion is relatively slow. So the thing is that this is why we need to breathe in oxygen or we need to breathe in and exhale, right? Because you can have diffusion, but it's not going to transport these molecules at a fast enough rate to supply your tissues. So again, diffusion does move, your gases do move via diffusion, but your respiratory system helps to speed up the process. It helps to move these gas molecule particles where they need to be. Now here we have respiration. So what we have is external respiration and internal respiration. So basically, external respiration is how you get, or actually pulmonary ventilation, let's back up a bit. So what does that mean? Well, pulmonary ventilation is just a fancy physiological term for breathing, right? And the thing is that you're moving air in and out of your lungs, and we showed the basic anatomy of how you get from your external environment out here into your lungs over here. So external respiration refers to the process of getting those oxygen molecules in from your environment into your lungs and to your blood. But this is where internal respiration happens. So internal respiration actually refers to the exchange of the blood and your tissues with the gases. So again, your red blood cells and the hemoglobin, you want to offload oxygen from the red blood cells into your tissues. And from your tissues, you want to, your tissues are going to generate carbon dioxide. And you want to convert that carbon dioxide into a form that it can be transported out of your tissues into your bloodstream. And that's internal respiration. So this exchange between the blood and the tissues, that's internal respiration. But when you go between the red blood cells end up back at your lungs, and also the plasma that contains a lot of bicarbonate, it's going to offload carbon dioxide back into your alveoli, and then you can exhale and breathe out that carbon dioxide. So basically, everything that's like to and from the alveoli from your environment, that's external respiration. But once it crosses that blood-air barrier and enters your plasma and your tissues, that's internal respiration. So again, there are two parts you need to actually get. So how do you get the gases into your body, but how do you actually distribute it to your tissues? That's internal respiration.